Okay, so today we talk about Iceberg charts. In the last two lessons, we used R and S charts to monitor variation within subgroups of data collected from processes over time. For example, we plotted the past dimension data on the R chart to look for unwanted sources of variation within subgroups of past. Now let's consider variation across subgroups of past. Is the variation between subgroups stable over time? To answer this question, we'll create an X bar chart. The X bar chart plots the sample mean for each subgroup over time. By plotting the means, the X bar chart monitors the process average over time and helps us spot unusual sources of variation between subgroups. Notice that we look at the R and S charts before considering the X bar chart. There is a reason for this. The X bar chart's upper and lower control limits are calculated using an estimate of within subgroup variation. For our control limits to be valid, it's important that the variation within our subgroup be stable. That's what the R and S charts do for us. They allow us to determine if within subgroup variation is in control. So let's return to the production line at a company. Every hour for 20 hours, the engineers collected samples of 5 parts and measure the dimension of each part. We collect 5 parts every hour as our rational subgroup because we believe there may be some variability from hour to hour on the production line. We then created an R chart by plotting subgroup ranges in a time order series. According to the R chart, the variation within subgroups is consistent over time. So we can now proceed to the X bar chart with confidence. Remember, the X bar chart monitors the process by graphing subgroup means over time. Let's do this for the path dimension data. The mean of the first subgroup is here. This is the first point on the X bar chart. The mean of the second subgroup is here, and this is the second point. We continue this for the remaining subgroups. And then connect the points. X bar is the mean of the subgroup means. X double bar is mean of the subgroup means. This value represents the central tendencies of our process. Now we calculate our center line and the control limits. The mean of the 20 subgroup means is here. We call this value X double bar and plot our center line here. Now we add the control limits. We draw upper control limit at 3 sigma limits above the center line. We use the estimate of within subgroup variation that we estimated from the R chart. The lower control limit is 3 sigma limits below the center line. For the path dimension data, the upper control limit is this one and the lower control limit is this one. Remember, a process is out of control if any points fall outside of the control limits or if a pattern is evident in the control chart. So that this chart suggests that the part manufacturing process is our control with respect to the mean path dimensions. So because no sample means are outside of the control limits and no patterns exist, so the subgroup means are in control. In general, we look at the H-bar and R-charts together on a combined H-bar R-chart. We first look at the within subgroup variation on the R-chart. If this is in control, we use this variation to plot control limits on the H-bar on the H-chart. Then we can determine if between subgroup variation is in control. So here another example. If the H-bar chart is out of control, then the process means are not stable over time. For example, look at these H-bar charts for two out of control processes. So which control chart is out of control because the sample means are increasing and decreasing over time in a non-random pattern? You can see the answer is A. The points are systematically increasing and decreasing, indicating that the samples are from two different populations. This control chart exhibits consistent shifts in mean values over time. The subgroups may consist of two paths that were made with two different parameters. We should investigate the process to find the cause of this pattern in mean path dimension. So how about the process in this H-bar chart? Here, mean values are increasing over time. It's possible that the different parameters may be causing the change. Again, we need to investigate the process further to find the sources of the increase. Okay, so far we look at the subgroups that have equal size. There are many processes. However, when subgroup size varies, bank collected data on the time it takes to process loan applications. Suppose they sample 5% of the applications they receive each week. The number of the applications varies from week to week, so the subgroup size varies as well. Let's look at the S and S-bar charts for the processing data on a combined S-bar and H chart. When subgroup size varies, the control limits associated with those subgroups vary as well. For larger sample sizes, the control limits are tighter, but for smaller sample sizes, the control limits are wider. When we have more data, we have more confidence in our estimates, and so we have narrower control limits. But when we have less data, we have less certainty. That's why we factor subgroup size into our control limits. Let's review. We use H-bar charts to monitor process mean over time. The upper and lower control limits are based on within subgroup variation and subgroup size. By looking for our control points and patterns in variation, we can use H-bar charts to help us spot special sources of variation in our processes. Thank you for listening.